Determine the equation of the two tangents to the circle which are parallel to the line 4x plus 3y plus 5 equals to 0. Let us begin. So here we will start with the given equation of the circle. We have x squared plus y squared minus 6x plus 4y. We'll transpose the 12 from the right hand side to the left hand side to get negative 12. This will be equals to 0. We are going to compare it with the general equation of a circle, which is given by x squared plus y squared plus 2 times gx plus 2 times f times y plus c equals to 0. Then we can immediately define 2g. So 2g will be equals to negative 6, which means g comes out to be negative 3. Then we have 2 times f, that will be equals to 4, which means the value of f will be 2. And then we have the c value, c is negative 12. Now we can immediately define the coordinates of the center of the circle. So that's going to be given by negative g comma negative f, which means our circle is going to have a center at 3 comma negative 2. And the radius is defined by square root of g squared plus f squared minus c. So if we substitute the value of g with negative 3, so we have negative 3 squared will give us positive 9. Then we have 2, which is the value of f, squaring it gives us positive 4. And then we have c value, which is negative 12, so we have positive 12. Now 9 plus 4, that's going to be 13. 13 plus 12 will be 25, so square root of 25 is going to be 5. That means the radius of the circle comes out to be 5 units. Okay. We will keep this aside for the time being. Next, we use the equation of the straight line 4x plus 3y plus 5 equals to 0. Our goal will be to find out a tangent which is parallel to this line. So we can suppose that let the equation of the tangent line, the equation of the tangent will be given by 4x plus 3y plus lambda. Now the reason we are writing it in this form, because the two lines is going to have an equal slope, because we know that parallel lines have equal slope. Only the y-intercept is going to be the difference. So that is determined by the value c of the constant term. So here we are considering it to be lambda. Now on our problem here, so here we have our circle whose coordinates of the center are we obtain as 3 comma negative 2. We have a line which is tangent to the circle, let's say at point A. The radius of the circle, so if the center is denoted by c, then CA is the radius of the circle. We found out that is 5 units. Now we have to find out the equation of the tangent, meaning we need to find out the value of lambda. So here what we can do, we can use the formula of the distance of the point C from the straight line. So let's find it out. We have CA, so CA will be equals to the absolute value. So what we'll do, we'll have to take ratio. In the numerator, we'll start with the x coordinate of the center, so that's 3. 3 will get multiplied to the coefficient of x of the straight line, so that's 4. This will be added to the y coordinate of the center, so that's negative 2. Negative 2 gets multiplied to the coefficient of y of the tangent line, that's 3, plus the constant term of the straight line, that's lambda, divided by the square root of, we need the sum of squares. The sum of squares will be defined as the coefficient of x, which is 4. We square it and add it to the square of the coefficient of y, so that's 3 squared. So let's further simplify. So CA, that's the radius of the circle, that was going to be r, which is a value equals to 5. And this will be equals to the absolute value of 3 times 4, that's 12. 12 minus 6 will be positive 6. We have 6 plus lambda divided by square root of 4 squared plus t squared, this will be 5. So we have absolute value of 6 plus lambda, that will be equals to 25. So let's solve for the value of lambda. So we have lambda plus 6, that will be equals to 25. Or the other possibility, lambda plus 6 could be equals to negative 25. The lambda will be equals to 25 minus 6, that's positive 19. And lambda will be equals to negative 6 minus 25, so that's negative 31. So we have the value of lambda. So we have obtained successfully the equation of the tangent. So we have 4x plus 3y plus lambda. We'll consider one lambda to be 19. This is going to be one equation of the tangent, and the other equation will be 4x plus 3y minus 31 equals to 0. So these are the these are the two equations of the tangent, and these tangent to the circle whose equation is given to us, and it is parallel to the line 4x plus 3y plus 5 equals to 0.